Welcome to Module 4. This is your roadmap to the DOT drug testing program. In the previous module, we covered alcohol testing. That system uses breathalyzers to measure immediate, real-time impairment, detecting alcohol on the spot if it is affecting you during your shift. The DOT 5-panel drug testing program operates on a different physiological timeline and regulatory structure. Laboratory analysis identifies substances processed by the body over days or weeks. This provides a record of use rather than a measurement of current intoxication. Because drugs stay in the system long after their active effects wear off, these rules focus on establishing a secure chain of custody for historical use. We will move through this module in a specific sequence, beginning at the clinic, examining each regulated substance, and concluding with emerging threats. Video 1 covers the collection process. We detail the strict physical rules and safeguards applied to your specimen before it leaves the facility. Videos 2 through 6 provide a dedicated deep dive into each substance on the DOT panel: cannabis, cocaine, amphetamines, opioids, and PCP. Video 7 addresses non-standard, emerging drug threats that sit outside the traditional 5-panel test. Walking through this curriculum explains how each regulation provides a specific layer of documentation to protect your career and the public. Testing begins in the controlled environment of a DOT-regulated clinic, where every step is designed to eliminate variables. To proceed with the test, you must provide a minimum volume of 45 milliliters of urine. Within 4 minutes of collection, the sample must register between 90 and 100 degrees Fahrenheit. This temperature range confirms the specimen is fresh and unadulterated. This division is the split specimen protocol. The 45 milliliter sample is poured into 2 separate containers to protect your right to a retest. Bottle A goes to the laboratory. Bottle B is held securely as a backup, ensuring an independent sample if a result is challenged. Minimum volume, temperature checks, and sample splitting establish the chain of custody required to protect the integrity of your result. If a driver arrives at the clinic and is physically unable to produce the required 45 milliliters, the staff initiates a specific set of procedures. This is known as the shy bladder protocol, a procedural safeguard designed to accommodate physiological difficulties. The regulations classify an initial inability to provide 45 milliliters as a physiological delay rather than a refusal or a failure. You are given a window of up to 3 hours to produce a sufficient sample. During this time, the clinic provides specific, supervised amounts of water to safely facilitate the collection process. The shy bladder protocol accommodates physiological difficulties while maintaining federal security standards. After the clinic stage is complete, the process moves to chemical analysis at a certified laboratory. Laboratories detect metabolites, the inactive byproducts left behind in the body after a substance has been processed. Because laboratories detect these lingering metabolites, a positive result indicates use within a specific window of time, distinguishing historical usage from immediate impairment. Due to this delayed biological timeline, the DOT requires a medical review officer to interpret every result. The MRO is an independent, licensed physician who reviews laboratory data before any verification is sent to an employer. Their primary role is to interview the driver to determine if a valid medical prescription explains the detected metabolites. The NIDING chemical detection with independent medical oversight provides a pathway to verify lawful, prescribed medical treatments. This roadmap has bridged the gap between alcohol and drug testing logic and outlined the strict requirements for specimen collection. Every step in this process, from temperature checks to the shy bladder protocol, exists to ensure a secure and fair result for the driver. In the next video, we follow the physical journey of a collected specimen through the testing lifecycle. Take this foundational knowledge into the next lesson. We will see you there.